progression, right? The whole essay is regarding arithmetic progression, right? So then, being that the case, you can understand if you want to do the essay completely, focus more on arithmetic progression. There'll be one question, might be, right? If you see, I think 2016 and 17, after 2017, 18, 19, 20, 21, 22, 23, 24, all those 8 years of 7 years of past paper, only arithmetic progression, right? 16 and 17, you have a bit of geometric progression. Those are also easy. I think you guys can focus it by yourself, right? So 5 questions, 5 essays of arithmetic progression. I think we can finish it quickly today with a good understanding, right? Now, bit of a idea before starting the question on what is arithmetic progression. First of all, you have number system, right? In your oral syllabus, there are two types of number system. One is your arithmetic progression, the other is your geometric progression, right? Now, what is arithmetic progression? You know, number system. Number system consists of set of numbers, right? Now, this arithmetic progression has a rule. What is the rule? Between two consecutive numbers. Consecutive means one number after the other, right? So then between two consecutive numbers, right? The gap is always equal, right? Between two consecutive numbers, I'm telling in my own words, okay, I'll tell you the proper definition, right? The gap is always equal, right? The proper term to put is the difference between two consecutive numbers is always the same or always equal, right? So difference means subtraction. When you subtract the number after by the number before, remember it's always number after by before, it's always the same if you take any two consecutive numbers. For example, if I take here, I'm doing well, Brian, thank you for asking, right? So then if I take here, let's say I have 3, right? 8, 13, 18, 23. Let's say this is a number system, number pattern given to you. This number pattern, you have to confirm whether it's an arithmetic progression or not, right? Now, for you to say it's an arithmetic progression, what must be the thing? For what should you satisfy? You should check whether between two consecutive numbers, does it always have the same value, right? So if I take these two consecutive numbers, consecutive means number one after the other, right? So if I take these two numbers, I have to check, right? What is the gap in between them? Now there is a word for that. That is called a common difference, right? So always common means same, difference means you subtract one number from the other, right? So same difference should be there throughout the number pattern. Okay. Board is blur. Wait, maybe it's not focusing. How is it now?
No, sir, it's very unclear. Like it's not
Now
clear.
okay. Is it okay now?
No, sir, it's still unclear.
Others? Same.
Yes, sir. Same, sir.
Same. Okay. Wait. Wait, I'll change the connection. Give me a moment. Wait, let me change the connection. Give me a moment. I'm switching it on. Hello. Am I audible?
Yes,
Yes,
sir.
sir, you are very audible.
How is it now?
Good, sir.
Still not clear.
Still not clear. Still the same issue.
Yes, sir.
Yeah. How is it now? Guys?
Yes, it's better than before, but
Okay, we'll wait. Maybe I'll just continue the class. 5 minutes later, just let me know whether it's still the same issue.
okay, sir.
Okay. No.
Okay, sir.
But I have no other any other option. So I've changed the laptop. This laptop, I think the Wi-Fi ability to connect to the Wi-Fi is not very strong, right? Anyways, so then, like we were saying, right? So then arithmetic progression between two any consecutive numbers, right? We have to check there's something called the common difference. That is, we subtract. Always remember, common difference is we subtract the number after from the number before. That is 8 minus 3, that is equal to 5, right? So again, 13 minus 8, we'll check once more. Again, that is equal to 5. Again, 18 minus 13. See here. So if you always take any two consecutive numbers and then you get the common difference, right? There's the number after minus the number before. In simple terms to put it, the gap between two numbers. The gap is always, how do you always find the gap? The number after minus the number before, right? We'll take another example. Let's say we have 10, 8, 6, 4, likewise. Can someone tell me what is the common difference here?
2 minus 2.
Minus
Very good. Minus 2, not plus 2. Okay. So always the number after minus the number before. Right. So then 8 minus 10, not 10 minus 8. Right. So that is minus 2. 6 minus 8, again minus 2. So if you check always, right, it will be minus 2. A small trick I'll let you know. Right. Common difference will be positive if the number is increasing. Common difference will be negative if the number is decreasing, right? Just keep that in mind. Okay, right. Now, the thing is, after finding the common difference, that's okay, right? Now, when you have an arithmetic progression, let's take the example that we took here, right? We start with 3, 8, 13, 20, sorry, 18, 23, likewise. Right. Now here using this, let's say we have to find what is the 40th term, right? Now we can't keep on adding 5, 5, 5, 5, 5, 5 to get until the 40th term. To spend a lot of time, right? So then what do? You have an equation for that. We'll not discuss how we got the equation, but you have to know this equation, right? Now that is Tn is equal to A plus n minus 1 into D. Now this equation we use in order to find the value of any term in an arithmetic progression, right? Let's say we need to find the value of the 40th term, right? So we are finding the value of the 40th term, right? Now, see here, it's very important for you to understand the equation. You guys get confused between the value and the position of the term, right? Now, Tn here gives us the value of the term, right? Now, A means first term, right? First term in the equation, right? Now here, first term, N here gives us the position, right? Position of the term, right? And D here is the common difference. If you guys want this, please copy it down because you guys do get confused. Especially common difference first term, okay. You guys get confused between Tn and N here. Tn means the value of the term. If you want to find the 40th term, right? 40 is the position of the term. 40th term, the value we are going to find out. Okay, you will see we are going to find out the value of the 40th term. Okay, all right. Now we can apply the equation here. See, here we are finding the value of the 40th term, T40. All right. First term here, A is 3 plus. Now N is the position. We know the position, that is 40. 40 minus 1. D is the common difference. We found it before. That is equal to 5. You can easily find the common difference here. All right. So 3 plus 40 minus 1, that is 39. 39 into 5. Right. So 39 into 5, that is 195 plus 3, that is 198. Right. So then the 40th term, the value of the 40th term is 198. Okay. So don't get confused between the value of the term, right, and the position of the term. Very important for you to understand this. Okay. Now this equation, you can see there are 4 unknown terms: Tn, A, N and D. Tn, value of the term, A is the first term, N is the position of the term, D is the common difference. Right? Now, any of these can be unknown. Usually, they ask you to find the value of the term like this. Right? If not, they give you the value of the term, they ask you to find the position of the value of that term. Right? The position. Right? So usually these two are only unknown. A and D is usually given. But I'm not saying always they'll give you A and D. Sometimes they can give you the value, the first term, and the position of the term, and they tell you to find the common difference. Right? Like any equation, you have 4 terms here. Anything can be unknown. Be ready for anything. Right? As long as you know the equation, and if you know each of these terms here, what do they mean, you're good to go. Okay? All right. Now, the next part is, all right, now, usually this question is given as a case scenario. They give you a small case, right? Like the commonest example is a pattern arrangement. Let's say a boy, he has flower vases, right? He arranged these flower vases in a certain pattern. What is a pattern? Let's say he keeps 1 flower vase in the middle, three flower vases in the first circle, then 5 flower vases in the second circle, right? So then 7 flower vases in the third circle. Likewise, he makes a pattern using all the flower vases that he has in the garden. Now what they'll tell, write this as an arithmetic progression, right? So first he has 1 flower vase, then the first circle 3 flower vases, then 5, 7. Likewise, the number of flower vases increase in a certain arithmetic progression pattern. Okay. Now the first question they can ask you, how many flower vases in the 10th circle? Right? How many flower vases in the 10th circle? Right? Now the 10th circle is the position of the term. Right? So n is equal to 10. You have to find the value of Tn here, the value of the term. Right? You have to find the value of the 10th term. What they're asking for the number of flower vases in the 10th circle. Now another question they can ask you, they can tell, okay, one of the circle has, for example, let's say okay. Now let's say one of the circle has 21 vases, right? Then they'll tell you one of the circle. Look at the board, guys. Right? They'll tell you one of the circle has 21 vases. Which circle is that? Is it the 5th circle? Is it the 11th circle? Is it the 15th circle? You have to tell which circle has 21 vases, right? So now they are telling you there is a value called 21. We don't know which term it is. In other words, we don't know the position. So Tn, the value is known 21. You know the first term. You can find the common difference. Here 5 minus 3, the common difference is 2. Now you have to find which term, or in other words, which circle does this 21 belong to. Right? Now again we can apply Tn is equal to A plus n minus 1 into D. Right? Now we know the value of the term is 21. First term is equal to 1. Right? We have to find the value of n here. We know the common difference. Right? You can see here 1 plus this value. Right? So first of all, we have to find the value of n, right? We can get rid of the 1 here. Take the 1 to this side. 21 minus 1 is equal to n minus 1 into 2. 21 minus 1 is 20. That is equal to n minus 1 into 2. Multiplied, to remove the multiplication, do the division. 20 divided by 2 is 10. That is equal to n minus 1. Take the minus 1 to this side. 10 plus 1, that is equal to 11. That means on your 11th circle, there will be 21 flower vases. Is that clear, everyone? Is it understood until this point? This is an example, okay? We'll do further questions. You'll get the idea better. Any doubt? Right. Right. I think now the camera is okay. Many of you guys have message saying the camera is clear. Right. Good. Right. Good. 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 Yes. All right. Now another question they can ask you. Let's say they'll tell you, okay, this boy managed to make 25 circles using all the flower vase that he has. Continuing this question, that they'll tell you, this boy here managed to make 25 circles, right? Remember, the first one is not a circle, right? It's a key point. Usually they ask you this type of question. The first one is not a circle, right? The second term here is your first circle. Keeping that in mind, now they tell you this boy managed to make 25 circles using all the flower vase, okay, let's say flower vase that he has. The question is, find the number of flower vases that he has. Okay, find the number of flower vases that he has. Right now we know. Right now there is an equation for this. Now you're logically thinking without using the equation. What will you do? You will write all the 25. Now tell me, is the last term here, right? I told you he's making 25 circles, right? Think and tell me, is the last term, is it the 25th term or is it the 26th term? Yes, the last term here, is it the 25th term or the 26th term? He's making 25 circles. Very good, right? It's your 26th term, right? Why? The first term is not a circle, right? First term is just a flower pot at the center, right? If he is making 25 circles, right, that is without the first term. Now, if you include the first term, now that will become the 26th term, right? So that means we keep on without the equation, right? We know we have an equation to find the addition of all the terms in the arithmetic progression, right? We can add. You have an equation to add all the terms in the arithmetic progression. Now, without the equation, what should we do? We have to add the first term to the second term, third term, until the 26th term. We are going to find out that, right? Until the 26th term, right? If you need to find all the number of or total number of flower vases, what do you have to do? First, we have in the center you have one flower vase. First circle, 3 flowers. Then five flowers, 7 flowers. Likewise, until all the flowers available, you need to add it to find the total number of flowers. It's a bit of a hassle. right? So for that, we have an equation, right? That is Sn is equal to n over 2 into multiply, not added, here it's multiplication into A plus L. Sn means addition, right? Addition of the terms. Right now, here you have 26 terms. Addition of all the 26 terms, that will be Sn here, right? N means number of terms. How many terms are you adding, right? N means number of terms that you are going to add here. A means your first term. Write this down. These are important, right? For you to know what each of these terms in the equation means is very important. L here means the last term, right? So now we know in this arithmetic progression, we are adding from first to the 26th term. Your first term is 1 here, then your last term is your 26th term. We don't know the value, we have to find out that value to get the addition, right? So this is your equation, right? Now we are going to apply here to find the total number of flower vases in this pattern here, right? So S26, you are adding 26 terms, so S26 is equal to number of term is 26 terms divided by 2. Your first term is equal to 1. Then that means you have to find your last term, right? So last term is your 26th term. Now using the previous equation, we can find the 26th term. That is Tn is equal to A plus n minus 1 into D. Right? So T26 is equal to A is your first term, 1, N. N is the 26th term, so N is equal to 26 minus 1. Common difference is equal to 2. Right? So that means 1 plus 26 minus 1, that is 25. 25 into 2. 25 into 2 is 50. 50 plus 1, that is equal to 51. So that means the last circle, your last term is equal to 52. Right? Now you can put that 52 here. Right? So 26 divided by 2, that is 13. 13 into 1 plus 52, that is 53. Right? Now 53 into 13. 3 into 3 is 9. 3 into 5 is 15. Leave a space. 1 into 3 is 3. 1 into 5 is 5. 9, 8, 6. So that means in total, right, to make this pattern here, this boy must have, or he has 689 flower vases. Is that clear? So for your arithmetic progression, the main two equations to find the value of a term in the arithmetic progression, right? The 30th term, 40th term, whatever the term, to find in an arithmetic progression, you use this equation. Tn is equal to A plus n minus 1 into D. Tn is the, remember, value of the term. N here is the position of that value. Okay? Know the difference. A is the first term, D is the common difference. Now, to find the addition of the arithmetic progression, right? Let's say you need to add the first 25 terms, the first 50 terms, whatever it is, we use this equation. Sn is equal to n divided by 2 into A plus L, right? Sn means addition, the value of addition of the all the terms that you need. N is the number of terms you're going to add. A here is the first term, L is the last term that you are adding. The last term that you are adding is L there. Is it clear? That is all that you must know regarding arithmetic progression. I'm sorry. Yes, the last term is 51. Thank you. I don't know why I put 52. Sorry, yeah. To be 51. Okay, thank you for that. Any other doubts you have, guys? Can we move on to the questions? No. Any of this equation cannot be used in geometric progression, right? Geometric progression has a separate set of equation. As I mentioned, I won't be discussing it today, right? Right. Right. Sorry for the mistake I did there. I think that's what you guys have the doubt. Right. This is not a question. Right. This is an example that I gave. Right. Now we'll move on to the question. Right. Take on the 2015. One of the easiest question to do, huh? Right? Because it's the same pattern that they follow always in arithmetic progression. Just these two equations, nothing else, right? These two equations, if you memorize or if you remember, that's it. Right. 2015. Pick out your questions, right? Isuri starts saving money by depositing rupees 5 in her till on the first day. On the first day, she's putting 5 rupees inside the till. After that, every day she deposits 2 rupees more than the amount she deposited in the till on the previous day. That means on the first day, if she puts 5 rupees, on the second day, she's putting 2 rupees more than the first day. First day, 5 rupees. What is 2 rupees more than the first day? That is 7 rupees. Then on the third day, 2 rupees more than 7. That is 9 rupees. So that means you can see, right, the amount of money she's putting inside the till is an arithmetic progression, right? So if you write down that the amount of money she's putting inside the till on the first day, 5 rupees. Second day, 2 rupees more than 5, 7. Third day, 2 rupees more than 7, 9. So likewise, always 2 rupees more than the previous day, right? So that follows an arithmetic progression. Okay, right. Roman number 1. Write in terms of n an expression for Tn. The amount of money Isuri deposits in the till on the nth day and thereby find the amount of money she deposits in the till on the 26th day, right? So first of all, right now, usually this question, what they ask you is for you to modify this Tn equation for this specific arithmetic progression, right? Now, you know the general equation, general Tn is equal to a plus n minus 1 into d, right? Now, what you can do for this question only, you know the first term and you know the common difference. You can substitute the value of the first term and the common difference and derive an equation just for this arithmetic progression like this here. So Tn is equal to, now you know the first term and the common difference can never change for a specific arithmetic progression, right? So first term is 5 plus n minus 1. The common difference. What is the common difference here, everyone?
2.
Very good. 2. Right? Into 2. Now what you can do, 5 plus, open the bracket here, 2 into n is 2n, 2 into minus 1 is equal to minus 2. 5 minus 2 is 3. So that means for this, see here, for this arithmetic progression, we can modify this equation and get Tn is equal to 2n plus 3. That means from here onwards, we are going to use this equation because already we have substituted for A and D. A and D substituted, done. It will never change for this question, right? So from now onwards, we are not going to start from here. We can start from this equation. Did everyone understand that? Yes? Did you get the idea?
Yes,
sir.
Right, great. So that means now they are saying, after you get an equation specific for this arithmetic progression, they are telling you to find the value of the 26th term, right? So T26 is equal to, now we can use this equation here, 2 into 26th term. We are finding the value, we are finding Tn, okay? We know the n is equal to 26, right? So 2 into 26, that is 52 plus 3, so that is 55. So that means on the 26th day, if you continue like this, on the 26th day, she will put 55 rupees into the till, right? All right. Row number 2. Write in terms of n an expression for Sn. Sn is the sum of the terms, the total amount of money in the till at the end of the nth day, and by simplifying, show that Sn is equal to n into n plus 4. Same thing. Okay. Now you know Sn is equal to, now usually recent question is 2015, okay, 10 years ago. Recent question, they don't ask these type of questions. You'll see, we are going to do 2023, 2024, right? The question pattern is a bit different, right? They don't ask you to find the value in the nth term for Tn, derive an equation for Sn. Those kind of questions are a bit outdated now. They do not ask, right? But you have to understand what's happening here, right? So Sn is equal to n divided by 2 into A plus L, right? Now see here, we need to substitute. Now we have n over 2. Only n should be in the equation. Now we know the first term, 5 here. Now the last term we don't know. We have to find for the nth term. That means we can find the value of the last term in terms of the nth term, right? So in terms of the nth term here, if I substitute for this equation, Tn is equal to a plus n minus 1 into d. If I assume n is my last term, I can put the value of n here and I will get, for the last term, Tn is equal to what? 2n plus 3. So that is my last term, 2n plus 3 in terms of n. Okay. All right. So n over 2 plus 5 plus 3, that is equal to 8. Right. So 2n plus 8. Now 2n and 8, the common term is 2. I can take the 2 outside, n over 2 into, I take the 2 outside, I have n plus 4. See here? Common 2, 8, if I take 2 outside, I have 4 here. 2 and 2, I can cut it off. Then I have n into n plus 4. That is the value of Sn in terms of n here. Right? Now what we can do, right? Roman number 3. Show
Excuse me,
that.
sir.
Yes, Bila?
So can you explain that part again?
Okay, right. See now, don't get confused. We are finding the last term in terms of n, right? Now let's say the last term is equal to n here, right? So last term is your nth term. We don't know. Nth term can be the 20th term, can be the 25th term, whatever it is, right? Nth term is the last term. Assuming that we can apply the Tn equation. Tn is equal to a plus n minus 1 into d, right? Now let's say your last term is, the value is equal to n. So last term is equal to a plus n is your last term. We know the value of the first term, that is equal to 5. N minus 1, the common difference is equal to 2. Right? So 5 plus, open the bracket here, 2 into n is 2n, 2 into minus 1 is minus 2. So you get 2n, 5 minus 2, that is equal to 2n plus 3. So the last term in terms of n here, that is equal to 2n plus 3. Right? Now we can simplify. 5 plus 3 is 8, 2n is here. Take the 2 outside. I have 2 into n plus 4. 2 and 2 cut it off. You have Sn is equal to n into n plus 4. Is that clear?
Yes, sir. Thank you.
Right. Problem number 3. Show that the amount of money in the till at the end of the 26th day is 780. So first day she's putting 5 rupees, then 7, then 9, 11, 13. Likewise, until the 26th day, she's putting money inside the till. Right? So that means, now remember, this is not the money inside the till. This is the amount of money she's putting inside the till every day. Right? So now, to find here, see here, we have got the equation. Don't bother to apply from the beginning again. Now we need to find for the 26th day, right? For the 26th day, S26, what is the total amount of money inside the till? N is equal to 26 here, inside the bracket, N is 26 plus 4. 26 plus 4, that is 30, sorry, multiplied by 30, right? So then 26 into 3, 6 into 3 is 18, 2 into 3 is 6, plus 1, 7. 26 into 3 is 78, add a 0. So that means on the 26th day, right? After she puts money on the 26th day, the total money inside the till will be 780 rupees. Is that clear? Okay, right.
Okay, sir.
Even if you apply the equation from the beginning, you'll get the same answer. But why waste time? You have already derived the equation in terms of n here, right? Otherwise, again, you have to find the last term. You have to find the value of the 26th term, then apply the equation and get the Sn value or the S26 value. Okay, finally, in order that the amount of money in the till at the 30th day is rupees 1100, Isuri deposits from the 27th day X rupees more than the amount deposited on the previous day. Write down an equation in X and find the value of X by solving it. Okay. Now, by the end of the 30th day, now by the end of the 26th day, she has 780 rupees. Then 27th day, 28th day, 29th day, 30th day. 4 more days, she wants the money to be equal to how much? 1100, right? 4 more days, she wants the money to be equal to 1100, right? Now see here, 26th day, the value on the till is equal to 780. On the 30th day, the value in the till must be 1100, right? Now, we know always she is adding how much? 2 rupees more than the previous day. Now, to get to 1100, she's adding X rupees more than the amount she deposited. We need to find out now what is the new extra amount she's adding than the previous day, right? Now, for that, definitely we need to figure out, right? We need to figure out what is the common difference, right? We need to figure out what is the common difference. Now you have a new common difference, right? So that means, see here, we can find out the 26th, right? We can find out the 26th, T26, right? Now we have n over, a plus n minus 1 into d, right? So then a is equal to 5, n is 26, 26 minus 1. The common difference that is equal to 2, 5 plus 25 into 2. So then we have 55. That means on the 26th day, she has put 55 rupees, right? Now, on the next day, she's supposed to put, see here. Wait. Right. So on the next day, now she's supposed to put 57, 59, and 61. 27, 28, 29, 63. Right. These are the amounts of money that she will put in her till. Okay. All right. Let me think of the easiest way to find it out, right? Wait. So then usually she puts X, 55 plus 2, 57 plus 2. But now you need 55 plus X. Then this amount here, 55 plus X, then 55 plus 2X, right? So then we can do here. See here? Now here we have 55 plus X. You will get the amount of money here. On the next day, she's going to add one more X here. Then again, one more X. Then again, one more X. So altogether, she's going to add 4 X's, right? Starting from 55, 1 X here, get the value. Then another X here, get the value, and another X here. Likewise, you get the last value here. How much will you get? 26, 27, 28, 29, 30. Right. So the last value that you will get 55 plus 4x. Right? You get here, the last value is equal to 55 plus 4x, right? Now what you can do here, you can apply the Tn equation, right? Tn is equal to a plus n minus 1 into d, right? So now we know the value of the last term, that is 55 plus 4x. The first term here is equal. Now we are already, these are like a new arithmetic progression, right? For the first term, we have 55 here plus n minus 1, right? So then 1, 2, 3, 4, 5. 5 minus 1, the common difference is equal to x here. All right. So we have 55 plus 4x, that is equal to 55, open the bracket, 5 into x here, 5 into minus 1. So then 4, we can do this, right? 4 minus 1 is equal to, okay, we're going to equalize on both the sides. No, that won't work out. What can we do here? Any ideas? 1100. Yes.
We can
So
use
what
the
the-
SN equation.
We can use the SN equation. Okay. SN
Sir.
equation. We'll try that.
Not the-
We'll try that. Try using the SN equation. So we know from 1100 to 780. What is the difference? 1100 minus 780. So we have 0, borrow 10 and 0 here. 8 from 10 is 2. 7 from 3 is 320. So for these 5 terms, if you add, you get 320. That is equal to number of terms is equal to 5. 5 divided by 2 into the first term is your 26th term, that is 55 plus the last term here, that is 55 plus 4x. 55 plus 4x, right? So we have 320 plus, sorry, that is equal to 5 over 2 into, add it, right? We can take like this. Here 55 plus 55 is 110 plus 4x. Okay. Take the 2 outside. Sorry. 320. 5 over 2. Take the 2 outside. Then you have 55 plus 2x. Cut the 2 and 2. Then you have 320. Sorry, 5 into 5, that is how much? 250, 275 plus 5 into 2, that is 10x. Bring the 275 here. 320 minus 275 is equal to 10x. 320 minus 275, that is 45. 45, that is equal to 10x. Divide both by 10 here. You get x is equal to 4.5. Is that the answer? Is that the x value that you get? That is 4.5 rupees each the next day.
No, sir, not this equation. I meant the SN equals the other one, n over 2a plus n minus 1, that equation.
Yeah, I use that equation only. Sn is equal to n over 2a plus. Now the first term here, that is equal to 55, right? That is your 26th term. Now you have 26th term, 27th term, 28th term, 29th term, and the 30th term, right? So then starting on the first day, right? Here, let's say this as your first term, 55. Then she's adding x rupees now. Now, before she added 2 rupees, now she's adding x rupees. We don't know what's the x rupees, right? So 55 here. Now 55 plus x here, right? Then the next day, x more rupees. 55 plus 2x. 55 plus 3x. 55 plus 4x. So your last term is 55 plus 4x. First term is 55. Number of terms here. Number of terms is it equal to 320? Now we started from here. No. We have to add 55 more here. Guys, I'll find the easiest way. I don't think this is the most easiest way to do
Excuse me,
it.
sir.
Yeah.
what if we take 320 divided by 4 and get the
No,
value?
you can't divide by 4 because each of these terms here is not the same, right? So you can't divide by 4, can you?
Isn't
You can't.
arithmetic equation common difference? Arithmetic equation is in the common difference.
Yeah, it's common difference, but each of the term here is just because you divide by 4. Now each term here is different, right? If you divide by 4, you won't get the answer. Okay.
Oh,
So isn't that n is 4? Yeah,
That's
sir.
how it's
Instead of
n
putting
is 4, right? Yeah. N should
n
be
should be
4.
4.
So if we can do like this, n is equal to 4 and this first term, that means we have to take this as the first term, right? Okay, that we can do that. I think we have to make that change. Maybe there's an easier method, but for now, this is all I can think of, right? So 55 plus x plus your last term is 55 plus 4x. I think that will work, right? We'll try that. So then here we have 55, 110 plus 5x. Now we'll cross multiply here then, 640, open the bracket, 5 into 110, 550, 5 into 5, that is 25x. Now solve this, bring the 550 to this side. So then, here, wait, 4, right? 440. I have to change that also. Bring it to this side. So then that is equal to 640 minus 440. That is equal to 25x. So here you have 200. Now that I think this should be the answer. Divide by 25, divide by 25. X is equal to rupees 8. So that means every day she has to add. Before she has added 2 rupees than the previous amount. Now to get to 1100, she has to add 8 rupees every other day. Right.
Excuse me, sir.
Yes.
So shouldn't it be 20x?
20x? How is it 20x?
4 and
Ah,
4
okay,
into
okay. I didn't change everything. My bad. 20, right? Okay. Okay, that means 10 rupees, right?
Yeah.
Okay, I'll start again, right? I messed up a little, right? Now look at the board, everyone. Look at the board. So that means on the 26th day, look at the board, guys. On the 26th day, this person had 780 rupees inside the till. Now, using the previous amount, adding 2 rupees the other day, I mean, not adding 2 rupees, increasing the amount she's adding for 2 rupees, right? Won't get it to her for 1100. She wants 1100 at the end of the 30th day. Now they're asking, instead of adding 2 rupees more for the previous amount, how much more money she should add? That is 2 rupees, something more than 2 rupees for her to achieve 1100. That means on the 30th day, inside her till, it should be 1100. Right? Now, we have to find out what is the amount she's putting inside the till on the 26th day. Right? Now, we can apply the TN equation to find out what is the amount she's adding on the 26th day. Right? Now, Tn, we can find T26. This is for the previous arithmetic progression, right? Your first term, how much was it? 5 rupees. Then 26 minus 1. The common difference was equal to 2. This is for the previous one, right? So 5 plus 25 into 2, that gives you 55. That means on the 26th day here, she has put 55 rupees into the till. Right. Now we know she's adding another amount to this previous amount, right? For her to achieve 1100. Let's take it as X rupees. That means on the 27th day, 55 plus X. Then again, she's adding the same X amount plus X here to get on the 28th day, 55X plus X is 2X. Likewise, 29th day also adding another X rupees. So in the 29th day, you have 55 plus 3X. Right? I'll put the 30th day down here. 30th day, she's adding X more, 55 plus X, one more X, that is 55 plus 3X, 4X. right? So that means at the 30th day, she should have 1100 inside her till, right? Now we can't connect this to the previous arithmetic progression. Why? Now the common difference has changed. Previously, the common difference was equal to 2 rupees. Now the common difference is X rupees. So it's a different. Now we consider this a different arithmetic progression, right? Considering this a different arithmetic progression, we have to know the sum of the new arithmetic progression. That means removing this, see here, on the 26th day, the amount was 780. 30th day, it must be 1100. So adding this plus this plus this plus this should give you how much? Should give you 1100 minus 780. That is 320. Right? So 1100 minus 780, 320. Adding all of these of these four terms should give you 320, right? So then this is a new arithmetic progression. We can apply the sum formula for this new arithmetic progression, right? So sum of these four terms, I'll do it here again. Right? We can apply the sum formula again for this new arithmetic progression, right? Sn is equal to n divided by 2 into a plus n. So then sum of these four terms, right? These four terms is equal to number of terms is 4 now, divided by 2. Now your first term is this 55 plus x. Plus your last term is this now 55 plus 4x. Now we know sum of these four terms is 1100 minus 780, that is 320. 4 over 2 into 55 plus 55, 110, x plus 4x, that is 5x. You can divide here, it's easier that way. 320 is 4 divided by 2, that is 2, into 110 plus 5x. Open the bracket, 2 into 110, 220. 2 into 5, that is how much? 10x. Now, what you can do, bring the 220 here. 320 minus 220, that is equal to 10x. Subtract, that is 100. That is equal to 10x. Divide by 10 here. So x is equal to rupees 10. So that means previously she increased 2 rupees more than the previous day. But now, in order to for her till to be 1100, she should add 10 rupees. Only for the last 4 days, she should add 10 rupees more than the previous day. Is it clear, everyone, now? Is it understood? Now, is it necessary for you to apply the formula? No. On that hurriness, if I understood this question like this, what will I do, right? If it didn't hit you, okay, I should apply the formula. What is the other easiest way? Only 4 terms, right? Add these 4 terms, right? I will tell 55 plus x plus 55 plus 2x plus 55 plus 3x plus 55 plus 4x is equal to 320. This also should give you marks, definitely, right? But this one, I think this one will be a much more, if you're putting calculation, much more faster method, right? And I think this is a more neater method. A good student would answer like this, but answering like this doesn't mean you will lose marks. Definitely, you will gain marks as well. Is that clear, everyone?
Yes, sir.
Yes? Right. We'll go to the next
Yes.
one, 2018. Okay, let me drink some water. Okay, now we'll move on. 2018. Okay, Now, a decoration consists of several circles containing small bulbs. There are 5 bulbs in the first circle, 9 bulbs in the second, 13 bulbs in the third circle, and so on. Starting from the first circle, when the number of bulbs in each of the circle is considered in order, they are in an arithmetic progression. So first circle 5, second circle 9, third circle 13, and so on. And they have confirmed it saying this is a arithmetic progression. Okay. All right. How many bulbs are there in the 10th circle? A straightforward, right? In the 10th circle, how many bulbs are there? You apply the Tn equation. Tn is equal to A plus n minus 1 into D. T10, they ask you the value, right? The value. They ask you the value of the 10th term. So first term is 5, n minus 1, right? 10 minus 1, you know it's the 10th term, into the common difference, 9 minus 5, that is 4, right? So 5 plus 10 minus 1 is 9, 9 into 4, 9 into 4 is 36, 36 plus 5, that is equal to 41. So in the 10th circle, you will have 41 bulbs, right? Roman number 2. Now again, if the total number of bulbs in the first n circle is Sn, show that Sn is equal to n in the bracket 2n plus 3. Right? Now you know Sn is equal to n over 2 into A plus L. Okay. Now they again, same like before, they have found the last term in terms of n. Right? You can find the last term using the Tn equation, A plus n minus 1 into D. Right? Now the last term is equal to A plus. N is your last term. It can be your 10th term, 15th term, whatever it is. We take n as your last term. Right? N minus 1. The common difference is equal to 4 here. Right? So first term we can put that is 5. So 5 plus, open the bracket, 4 into n, that is 4n. 4 into minus 4, minus 4. 5 minus 4, that is equal to 4n minus 1. So your last term in terms of n, that is 4n minus 1. Now you can apply this equation. Sn is equal to n over 2. Your first term, that is equal to 5 here. Your last term, 4n minus 1. Right? So n over 2 into 5 minus 4, that is 4. So 4n minus 4. You can remove this denominator. If you take the 2 outside here, right? We can take 2 outside. I have 2n minus 2. Cut the 2 and 2 here. What do you remain with? N, not minus, plus. 5 minus 1, that is plus 4. Right? Should be plus. Right? So Sn is equal to n into 2n plus 4. Wait, plus 3. Wait. My bad. 5 minus 4, that is plus 1. I am sorry. Plus 1. 5 plus 1, that is 6. So here you have 3. Okay? Right. Sorry about that. Roman number 3. Okay? If the decoration consists of 40 circles, find the total number of bulbs in the decoration. So they are saying the last circle is your 40th circle. In other words, there are 40 circles in the decoration. Now we have already derived the equation or the Sn formula, right? We have substituted for all. Only n is missing. So we know n is equal to 40. We can put the 40 there, right? So 40 in the bracket, 2 into 40 plus 3. So then 40 in the bracket, 2 into 40 is 80. 80 plus 3 is 83. So into 83. Right? 4 into 83, that will give you 320, 332. 332 at the 0. So in total, there will be 3,320 bulbs. Okay. Now see there, among the circles, starting from the 10th circle, every circle which counts as multiples of 5 consists of only yellow bulbs while all the other bulbs are red. Find the number of red bulbs in the decoration. Right. Now look at the board. See here. Wait, where is the now? I'll erase this. So they are telling you among the circles starting from the 10th circle, right? So then let's say 5, 9, 13, common difference is 4 here. So then add 4 more, 17, 21. So likewise, in the 10th circle, starting from the 10th circle, every circle which counts as multiple of 5 consists of only yellow bulbs while all the other bulbs are red. Find the red bulbs in the decoration, right? So now what can we do here? The best thing to do is for you to find, now see, in the 10th circle, find how many bulbs are there. Starting from the 10th circle, there are yellow bulbs in each multiple of 10, right? So 10th circle, 15th circle, 20th circle, 25th circle, 30, 35, 40. I'm just giving you an idea, right? So then in the 10th circle, now you know it's arithmetic progression, right? Now we can find, first of all, only for the 10th circle, how many bulbs are there? We can apply the TN equation, right? I'll do it down here. Look at the board down. Huh? So then we can apply for the 10th circle. T10 is equal to A. A is your first term, right? First term is 5 plus n minus 1. We are finding for the 10th circle. Did we find for the 10th circle? We did, right? How much was that? How much was Roman number 1? Guys, Roman number 1 was what was the answer?
41 bulbs.
41. So in the 10th circle, there are 41 bulbs. We can find for the 15th circle, right? I'll get the answer. Look at the board. 15th circle, right? 15 minus 1, common difference is 4, right? So 5 plus 15 minus 1 is 14. 14 into 4, right? 14 into 4, that is equal to how much? 64 is it? 14 into 4, 40, 56. 56 plus 5, that is equal to 61. Right. So now 61 here. Now you know this follows an arithmetic progression. So you don't have to apply the equation now every time. Right. Now what you can do, so the difference between the 10th and the 15th term is 20. 15th and the 20th term also must be 20. So here should be 81. Here also must be 20. This should be 101. Likewise, we can get a new arithmetic progression just for the yellow bulbs, right? Now for the yellow bulbs, what we can do, we can get a new arithmetic progression. That is, first term is 41, then you have 61, then 81, and likewise. Now, why do we need a new arithmetic progression? Then only we can apply this SN formula to find the number of yellow bulbs. If you find the number of yellow bulbs, you know the total number of bulbs. Total number of bulbs minus the number of yellow bulbs will give you the number of red bulbs. That is the idea we're going to have here, right? So that means we found out in the Roman number 1, there's a reason they gave you this Roman number 3 starting from the 10th. Why? Because they already know you have found for the Roman number 1. In the 10th circle, you have 41 bulbs. Even using your logic, even without applying this formula, you can see here there are how many terms here? There are 5 terms, 10 to 15, 5 terms. We know the difference between each term is 4. So 4 into 5, that is 20. So difference between the 10th and the 15th term, that will be equal to 20. Right? So you can find out the 15th term even without applying the formula. But I think they do give marks for the formula and applying here to find the 15th term. I don't know. Maybe they do give it, right? So better to apply the formula and get the answer here. Then you can write for the yellow bulbs, you get the arithmetic progression 41, 61, 81. Now you must know how many terms are there, right? Now better to get all the terms here, just adding 20, nothing difficult. Right? Keep on adding 20. So then 10th, 15th, 20th, then 25th, then 30th, 35th, and then the 40th. Now we know the first and the last term. Now what we can do, apply the SN equation. Right? Now you know, right, Sn is equal to, right, how many? 1, 2, 3, 4, 5, 6, 7 terms. S7 is equal to 7 divided by 2 into A plus L. Your first term is 41, your last term is 161. Right? So 7 over 2, 41 plus 161, that is 202. Right? 202 divided by 2, that is 101. 101 into 7, that is 707 bulbs. So that means there are 707 yellow bulbs. Now in Roman number 3, you found out the total number of bulbs. How much was there? There were 3,320 bulbs. That is the total number minus the number of yellow bulbs. That will give you the number of red bulbs. So how much is that? So then if you borrow here, this will become 10, this will become 1, 7 minus 10, that is 3, 0 from 1 is 1. Then 7 from 33, that is equal to 26. So in total, the number of red bulbs is equal to 2,613. Is that clear? Is that clear, guys?
Excuse me, sir.
Bianca?
Sir, can you please explain how you got that number of yellow bulbs?
Number of yellow bulbs?
Yeah, sir. The
Okay,
700, sir.
Yeah, now see here, back again, the number of yellow bulbs. Now we know, then they are telling you, read the question carefully. The question is saying, then among the circles, starting from the 10th circle, every circle which counts as a multiple of 5 consists of only yellow bulbs. That means your 10th circle has yellow bulbs. Then after that, every multiple of 5, 15th, 20th, 25th, 30th, 35th. Likewise, every multiple of 5 has yellow bulbs. Okay. Now, having that idea, your 10th circle, we already found out Roman number 1, there are 41 bulbs. So then there are first, in the 10th circle, you have 41 bulbs. 15th circle, 5 terms more. Between each term, there is gap is 4. The common difference is 4. After 5 terms, that means now the gap will be 20. Your 15th term should be equal to 61. Likewise, the difference between each yellow circle, always 5 terms apart, the difference will be the same. So that is another arithmetic progression. So here the 10th circle is 41, then the 15th circle is 61, then the 20th circle is 81, then your 25th circle 101. Likewise, you can understand every yellow circle, if you arrange it, you get another arithmetic progression. First of all, did you understand that?
Yes, sir.
Right. Now, for this arithmetic progression, you can see there are 1, 2, 3, 4, 5, 6, 7 terms. We can apply the SN, same like you did before. Now, this is a new arithmetic progression. So, there are 7 terms, 7 over 2. First term is 41, last term is 161. You apply the equation, you get 707 bulbs. That means there are 707 yellow bulbs. Now, you know row number 3, we found out total number of bulbs is 3,320. Now, if you subtract the yellow bulbs, the remaining will be your red bulbs. Is that clear?
Yes, sir. Thank you.
You're welcome. Any other doubt?
So how do we know that the Sn, that n is 7?
So n is the number of terms. You're adding how many terms here? 1, 2, 3, 4, 5, 6, 7. So n is equal to 7.
But
Okay.
did they say like that we need to find 7 terms like that?
No, now what they said was every multiple of 5 is a yellow bulb. The circle is a yellow bulb starting from the 10th circle. So see here, 10th circle, that is your first yellow bulbs. 10th, 15th, 20th, 25th, 30th, 35th, 40th. So in total, there will be 7 circles with yellow bulbs. That is the value that I have found out here. Okay. Understood? guys?
Yes, sir.
Right. All right. That is your 2018.
Excuse me, sir.
Yeah.
Then can we, instead of 7, can we use the 5 also? Like, for example, I'm asking.
Instead of 7,
Like,
can we use 5? What does that mean?
I mean that instead of that S7, can't
Yeah.
we use the 5?
Why do we use 5? Now there are 7 terms. We need to find the total number of yellow buds. If you use 5 there, what will be your last term? You are adding all 7 buds here, all 7 circles to find the total number of yellow buds.
Yeah, sir, but they haven't say something like that 7 something like that, no, sir.
Yeah,
The
now what
total
they have
number.
said in the question here, among the circles, now there are 40 circles here. Right, you understand that, right? They said you, Roman number 3, if the decoration consists of 40 circles. So there are 40 circles in total. Now, Roman number 4 tells you, among these 40 circles, starting from the 10th circle, right? So on the 10th circle, every circle which counts as multiple of 5 consists of only yellow buds. So you know the multiple of 5. So starting from the 10th circle, what is the next multiple of 5?
10.
Now after 10, first is 10. What is the next multiple of 5?
15.
15. And again 20. So these multiples of 5 starting from 10, 10, 15, 20. In each of these circles, there is only yellow bulbs. Did you understand that?
Yeah.
Okay. So then on the 10th circle in Roman number 1, we found out there are 41 bulbs, right? So this is the 10th circle. The 10th circle, there are 41 bulbs. Likewise, we know the common difference is equal to 4, right? So 11 circle, there will be 45. Then 12, 4 more, 4 more, 4 more. So 15 circle, right? So from 10 to 15, there are 5 terms. Between each term, the difference is 4. So 5 terms, the difference between the 10th and the 15th circle will be 20. Did you understand that?
Yeah.
Yeah. So the 15th circle will have 21 bulbs, sorry, 20 bulbs more than the 10th circle. That is 41. At 20, you get 61. So then likewise, each multiple of 5, if you take, this is the 10th circle, 15th circle, the next multiple of 5, that is your 20th circle, will have 20 more bulbs, 81, 101. Until the 40th circle, every multiple of 5 has only yellow bulbs. So this is the 20th, sorry, 10th, 15th, 20th, 25th, 30th, 35th, 40th. Until 40th, every multiple of 5, the circle has only yellow buds. So if you count, that means there are 7 circles with yellow buds. They didn't tell you that, but they told you every multiple of 5 has yellow buds. Now, okay.
Yes, I now understood.
Okay,
Thank you.
good. Right, you're welcome. Any other doubts? Right, so we can now, after finding out this, the yellow bars, now that is a new arithmetic progression. We can treat it as a new arithmetic progression and apply the SN formula, get the total number of yellow bars. Now applying the SN formula, what does that mean? Simply you're just bored, or it's difficult for you to add all these, so you're applying one equation to get the addition of everything. That is your SN formula. After applying addition of everything, if you add everything, you'll get 707 bulbs. So that means total bulbs minus the yellow bulbs will give you the red bulbs. I hope that clears the doubt. Right. We'll move on to the next one. That's 2020. Always the last Roman number, you have to give a bit of a thought, right? It won't be a direct answer. Don't expect it to be a direct answer, right? But usually first 3 Roman numbers is usually pretty direct. Using the formula once, we'll get to the answer, right? But the last Roman number, you have to put bit of an effort, right? Think a little and answer. Right, the 20th one, a flower bed consists of 50 rows of red flowering shrubs and white flowering shrubs. There are red flowering shrubs at both end of each row, and between every two consecutive red flowering shrub, there is a white flowering shrub. Okay, what does that mean? Okay, we'll continue one more. We'll finish the sentence. There are 13 flowering shrubs in the first row, and each row thereafter has one red flowering shrub and one white flowering shrub more than the previous row. Right? So if you take the first row, look carefully. I'll put a cross for the red. Okay, crosses for the red and just a circle for the white. Just to give you an idea, what are they saying here? First row has what they have starting and ending. On the two corners, definitely you have a red flowering shrub. Okay. On the two corners, definitely you have a red flowering shrub. And also they said between each red flowering shrub, there is a white flowering shrub. So that means if you put another red flowering shrub here, in between there is a white flowering shrub. Okay, this is the idea they have given you. So here there is a white, then a red, white, then a red, white, then a red. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? This is your first row. Right? So then likewise on the next row, there is one more red and one more white. Right? So in the first row, if you have 13, if you have one more red, one more white, second row, how many will you have? How many flowering shrubs?
15.
15. Two more. Right? Then the next row as well, one more white, one more red, another two more. So likewise, you can see this is also a arithmetic progression. So row number 1, write the number of flowering shrub there in the first row, second and the third row. We have done that. How many flowering shrub in the 28th row? Right? 28th row, you can easily apply the Tn equation. Tn is equal to, they give you marks for the equation. So in the beginning, first write the equation. T28 is equal to, first term is 13, n minus 1. You are finding the 28th term, 28 minus 1. Common difference, 15 minus 13, that is equal to 2. 13 plus 28 minus 1 is 27. 27 into 2. 27 into 2, that is 54. 54 plus 13, that is 67 shrubs. Okay. So in the 28th row, you have 67 shrubs. Pretty direct, right? How many are there? Sorry, how many rows are there with less than 90 flowering shrubs? So first of all, you have to find out which row has 90 flowering shrubs. Okay. So you know there is a row with 90 flowering shrubs. So the value of the term is 90. You have to find the position of the term. Right? So if you apply the Tn equation, a plus n minus 1 into d, now you know the value of the term. You know the first term, you know the common difference. You have to find the position of the term. That is what we have to find. So Tn is equal to 90. First term is 13. n minus 1. The common difference is equal to 2. Bring the 13 to this side. Right? 90 minus 13 is equal to n minus 1 into 2. 90 minus 13, that is 77. n minus 1 into 2. Divide both sides by 2 here. 77 divided by 2, that is 38.5. Is that correct? 38.5, yes. Is equal to n minus 1. Take the minus 1 here. 38.5 plus 1. So that is 39.5. Now you know there can't be a row with 39.5. Right? So can someone tell me? Now you know imaginarily the 39.5 row will have 90 flowering shrubs. So that means 39th row will have more than 90 or less than 90? Yes. The 39.5 has 90. The 39th row, will it have more than 90 or less than 90?
Less than 90.
Less than 90. So the 40th row will have more than 90. So the 39th row is the last row where there is less than 90 flowering shrubs. And any row before that will definitely have less than 90. So tell me, in total, how many flowering shrubs have less than 90? So yeah, how many rows have less than 90 flowering shrubs? Is it 39 or is it 40? What should be the answer?
39.
39. Can't be 39. Don't give you answer 39.5. Okay, there is no row 39.5. That can't be a half row, right? So then the answer should be 39 rows. So there are 39 rows where there is less than 90 flowering shrubs. Okay, all right. Last one. Find the total number of flowering shrubs there are in the flowering bed. Okay, all right. So then you have to, first of all, first part of the question is to find the total number of flowering shrub in the bed, right? So you know in total there are 50 rows, right? We can apply the SN equation, A plus L. You have 50 rows. So you are finding the sum of the 50 rows, S50, N is equal to 50 divided by 2. First term is 13. You have to find the last term, right? You have to find what is the number of flowering shrubs in the last row. That is your 50th row, T50. A plus N minus 1 into D. First term is equal to 13. 50th row, 50 minus 1. The common difference is 2. You have 13, 50 minus 1 is 49, 49 into 2, right? 49 into 2, that is 98 plus 13, that is equal to 111, right? So then your last row will have 111 shrubs, right? So then 111 here, 50 divided by 2, that is 25, 25 into 13 plus 111, that is 124, right? 124. Right. So 124 into 25. 4 into 5, 20. 2 into 5, 10. 10 plus 2, 12. 1 into 5 is 5, plus 1, 6. Space here. 2 into 4, 8. 2 into 2, 4. 2 into 1, 2. 0, 10, 1, 11. Then in total, there are 3,100 shrubs. Is this clear, everyone?
Yes, sir.
Okay. Yes. Last part. How many more red flowering shrubs are there in the bed than white flowering shrubs? Okay. Can someone tell me the answer to this? Anyone found out? And I need the proper explanation, a logical explanation. Don't need to use big calculation and all of that sort, right? It's a simple answer. Simple logic. 15. Is that a recent answer? Anyone? Last row. Find the total number of flowering shrubs that we have done. How many more red flowering shrubs are there in the bed than white flowering shrubs? Anyone who knows the answer for this? And if you know the answer, you have to give me a small idea. Because you can look at the past paper and tell me, right? I don't think past paper gives you the idea, right? But don't need any formula to use. Use a bit of a brain, you'll get your answer. Anyone? First of all, tell me the answer. What's the answer? Yes, Ibrahim?
50.
50. What's the idea, Ibrahim?
So the amount of shrubs that get added every time is equal, right? White and red. So it
Exactly.
doesn't matter. So in one row there's like one more, right? And there's 50 rows, so it's like 50.
Exactly. Good. Right? So if you take the first row, see here, we'll check how many red and how many white. 1, 2, 3, 4, 5, 6, 7 red. If you take the white, 1, 2, 3, 4, 5, 6. So in the first row, there is one red more than white. Okay, always in the first row you can see here, there is one more red flower than the white flower. Now every time when they always add one red color, one white color. So equal number of red and white. So then when you come to the next row also, because you add equal number of red and white, The next row also, there will be one more red color flower than the white color. Then always when you add the equal number of red and white, every row will have one red color more than the white color shrubs. So then each row will have one red more than the white. So there are 50 rows. So in total, there are 50 shrubs. So row number 4, simple answer, 50 shrubs. There are 50 red color more shrubs than the white color ones. Is that clear?
So I didn't understand that.
Okay. Now, in your first row, right? In your first row, you have one red more than white. Did you understand that? Just counting, you get that one red more than white. Okay.
Yeah.
Okay. Now the
Okay.
next row, I'll quickly draw it for you. You'll get an idea then. On the next row, you are adding one white and one red. Okay. So then red color here, white, red, white, red, white, red, white, red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I'll add one more. White and red. Okay. Now again, if you count, see here, how many red? 1, 2, 3. Now this was 13. You added one red and one white to the next row. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Again, how many red more than white? Again, only one red more than white. Because always there will be only one red more than white. Why? Because you are adding equal number of red and white. So the difference between the red and white will not change because every row you keep on adding equal number of red and white. So every row there will be only one red color flower more than the white color, right? So each row will have one red more than white. There are 50 rows. So 1 into 50, that is 50 shrubs. Is that clear?
Yes.
Okay, good. All right, next one. 2023. Right, a decoration has been made by fixing blue and white bulbs in several concentric circles. The blue bulbs have been fixed such that the innermost first circle has 3 bulbs and each of the following circles have 3 more bulbs than the previous, right? That is a one design. Another design, another circles made up of white bulbs have been fixed that such that the innermost bulb have 2, then the next has 3, and the circle after that has 4 bulbs and so forth. Problem number 1, write the number of blue bulbs fixed in the first 3 circles respectively, right? So you have 2 designs. One is made up of blue color bulbs. The other circles made up of white color bulbs, right? Now, blue, white. Now the blue pattern, how is that made? First circle has 3 bulbs. Then you have 3 more bulbs than the previous, right? So first 3 more bulbs, 6, 3 more bulbs, 9. Here, first circle has 2, then 3, then 4, right? So then this is the pattern that the blue and the white follows. Problem number 1, write the number of blue bulbs in the first 3 circles that we have done already. How many more bulbs are there? How many more blue bulbs are there than the white bulbs in the 10th circle, right? Now in the 10th circle for blue color you can apply E10 is equal to A plus N minus 1 into D, right? Now your first term here is 3 plus 10th term 10 minus 1 into the common difference here is 3. 6 minus 3 is 3. So 3 plus 10 minus 1, that is 9. 9 into 3 is 27. 27 plus 3 is 30 bulbs. So in the blue pattern, there are 30 bulbs. In the white pattern, we'll see how much is that. T10, first term is 2. Then the 10th term, 10 minus 1, common difference. Here common difference is 1, right? So then 2 plus 10 minus 1 is 9. 9 into 1 is 9. So you have 11 bulbs. So then tell me, in the 10th circle, how many more blue bulbs than the white bulbs? Then you can write 30 minus 11, that is 19 bulbs. So there are 19 bulbs more in the 10th circle of the blue pattern than the white pattern. Okay? Any doubt here?
No, sir.
No. Last one. The number of circles in which bulbs have been fixed in the decoration is 16. Sunil states that a total of 550 blue and white bulbs are sufficient for this. Is his statement correct? Give reasons for your answers. I feel like this is one of the easiest questions they can give. Right? The whole, 2023, they say it's easy, right? So then you have to separately find out how many blue bulbs are there, how many white are there, add it and show whether it's 550 or not. Simple as that, right? So then for the blue bulbs, I can apply Sn is equal to n over 2 into A plus L, right? Then there are 16 circles in both blue and white. There are 16 circles, right? So then S16, 16 over 2 into first term in the blue color, this is for blue, right? First term in the blue color is 3. Then your last term, right? So then you can find out the last term. I'll find the last term here. Last term for the blue color, A plus L, A is equal to 3 plus A n minus 1. N is the last term is the 16th term, 16 minus 1. The common difference is also 3. So 3 plus 16 minus 1 is 15. 15 into 3 is 45 plus 3, 48. So the last term here, that is equal to 48. 16 divided by 2 is 8. 8 into 3 plus 48, that is 51. Right? 51 into 8. 50 into 8, 400. 8 into 1 is 8. Then 408 bulbs. This is for blue. We can do the same thing for white here. Sn is equal to n over 2 into A plus L. Right? So S16, number of circle is 16 over 2. Right? First term here is equal to 2. Then again you can find the last term for the white bulbs. L is equal to. Then A is 2 here plus n minus 1. 16 minus 1 common difference is 1. So then 2 plus 16 minus 1 is 15. 15 plus 15 into 1 is 15. 2 plus 15, that is 17. Right? So then 17 here, 16 divided by 2, that is 8. 8 into 2 plus 17 is 19. Right? Now the easiest way to multiply, imagine this as 20. 20 into 8 is 160. 1 less, right? So 1 less you have multiplied by 8. So 8 less. 120 minus 8, that is 112 bulbs. Now add both of them. 408 plus 112. How much is that? Yes. 10. 1 here. Then 1 plus 1, 2. 520. Is that correct? Did I mess up the calculation? Wait. 8 into 20. Sorry. 8 into 20 is 160 minus 8, 152. My bad. 152. So then 152, if you add it now, you get 560 bucks. So then in total, they're asking you, Sunil is saying 550 is enough. Then you can tell, no, you need 560. So then you can tell 560 is more than 550. So his statement, Sunil's statement is false. Okay? If you have any doubt, this question is easy, nothing confusing there. Any doubt here? Guys, yes or no?
No, sir.
No, right. Last one. 2024. Amala and Sumana, I don't know, right? Decides to read a certain novel during the holidays. Amala reads 20 pages on the first day, and on each day thereafter, she reads 3 pages more than the previous day. Write the number of pages that Amala reads on the first, second, and the third day, respectively. Okay? Don't ever skip the arithmetic progression. Easy, right? Not difficult. Just do again these questions, past 10 years of past paper, you get a better idea on your by yourself, right? So then write the number of pages Amala reads in the first 3 days. So first day she reads 20 pages. Then after 3 pages more than the previous day. So 23, 26, 29, likewise. Roman number 2. How many pages does Amala read on the 16th day? They ask you the value of the 16th term, T16. Then you can write first of all the equation Tn is equal to A plus n minus 1 into D. T16 is equal to the first term 20 plus n minus 1 number. We are finding the 16th term 16 minus 1. Common difference is equal to 3. So 20, 16 minus 1 is 15, 15 into 3. 50 into 3 is 45, 45 plus 20, that is 65 pages. So on the 16th day, she's reading 65 pages. If she completes the novel on the 16th day, how many pages does the novel consist? They are making things easier for you, right? Because this is like the last term, right? So 16th day is the last term. So now you can apply SN formula to find the sum. Sn is equal to n over 2 into A plus L. So you are finding the sum, addition of the first 16 terms. Number of term is 16 divided by 2. First term 20. Your last term is your 16th term, that is 65. Right? 16 divided by 2 is 8. 20 plus 65, 85. Do the multiplication. 8 into 8 is 640. 8 into 5, that is 40, 640 plus 40, 680 pages. Right? Then after, row number 4, how many pages does Sumana, all this time we are talking about Amala, how many pages does Sumana read on the first day if she takes 17 days to complete the novel, and if on each day after the first she reads 4 pages more than the previous day, right? Now they are asking you, Sumana now is taking 17 days, right? They are asking you how many pages does Sumana read on the first day. Now the first term is unknown, right, for Sumana, right? So now Sumana is reading 4 pages more than the previous day. So let's take the first term as A here. Then the second term is A plus 4. Then the third term, another plus 4, A plus 8. Likewise, she's reading. Now, she's taking 17 days more to complete than Amala, right? So then, we know the total number of pages. That the same novel, right? So again, there are total number of 680 pages. Okay. Now we can apply the SN formula, n over 2 into A plus L. Now we know in total anyway, Sumana also will read the same novel, 680, right? Total number of pages. Number of terms, she is reading in 17 days, so n is equal to 17 divided by 2. Now the first term is A here. Now last term, we have to find out in terms of A. Now what we can do, we can apply the Tn equation to find the last term, A plus n minus 1 into D. Now last term here, that is your T17, that is your last term, right? Last term, right? T17, that is your last term, remember. A plus, we don't know the value of A. We are going to find out the last term in terms of A. A plus, n is the 17th term, that's your last term. Now the common difference is 4, right? She's reading 4 pages than the previous day. A plus 17 minus 1, 16. 16 into 4, that is equal to 64. So the last term in terms of A, that is A plus 64, right? A plus 64. All right. Now if you solve this equation, we can find the value of A here, right? So 680 is equal to 17 divided by 2. Do the addition. A plus A is 2A. Right now here, if I do here, 2A plus 64. Now to get rid of the denominator, I can take the 2 outside. If I take the 2 outside, what will I have? A plus 32. Now I can cut this off here. open the bracket. 680 is equal to 17 into A, 17A, 17 into 32. I have to do that multiplication. Okay. So then 17 into 32, I'll do it down here. Or else I don't need to open the bracket. I'll make things easier. Otherwise, you have to do the division twice, right? 17 into A plus 32. Right, 17. Now what I can do, I can divide both sides by 17. So I do only the division once, not 2-3 times. Okay. So 680 divided by 17. We'll do the division. Then 17 into 1 is 17. 17 into 2, 34. 17 into 3, 51. 17 into 4, 68. Right? So 17 into 4 is 68. 0. Bring the 0 down. Another 0. So 680 divided by 17 is 40. Right? I have here A plus 32. Bring the 32 this side. A is equal to 40 minus 32. That is 8 pages. That means Sumana here is reading 8 pages on her first day. Right? So on her first day, Sumana is reading 8 pages. Yes, Ashwa?
Isn't it 2A?
Isn't it 2A? No, Ashwa, see here. Now what did I do? A plus A is 2A plus 64. Now I have here 2A plus 64. Then what did I do here? Here, I have 2A plus 64. Then what did I do? I took 2 as the common term. If I take 2 outside, I can cut this 2, right? And 64, if I divide by 2, I have 32, right? So I take 2 as common. Then I cut this 2 and 2. Now what do I have? 17 into A plus 32. Is that clear?
Yes, sir.
Right. Any other doubts? Any other doubt? No? Right. Last question. If two of them started reading the novel on the same day, on which day do they read the same number of pages? Right. So that means, see here, look at the board. I'll give you a logical approach to this. Right. So then, Sumana here, right, starts reading 13 pages, then 4 more pages, 4, 3. 20 pages, right? Amala writes 20 pages, then 3 more pages. Sorry, 20, then 23, then 26 likewise. Sumana here starts reading on the 8th page, then 4 pages more on the next day. Keep on adding 4 more pages, right? Now they are saying at one point, both of them will read the same number of pages. On one day, both of them will read. If 2 of them start reading the same novel, on which day do they read the same number of pages? Right? Now, that means on one day, they will read. For example, let's say Sumana here is reading 300 pages. Sorry, Amala is reading 300 pages. At the same day, Sumana is also reading 300 pages. Now, they're asking, what is that day? Now, that day, we'll take it as n there. Right? We'll take it as n. Right? Now, if I apply the Tn equation, we don't know how many pages are they reading. We don't need to know also. We just need to know on which day they are reading the same number of pages. So, if I apply for Amala here, the Tn equation, I erase this, right? Tn is equal to A plus n minus 1 into D. Now, between, can someone tell me, between Amala and Sumana, among these 4 terms, on the day they are reading the same number of pages, what is equal? What is equal? Is it Tn? Is it A? Is it N? Or is it D?
D.
Yes? Now A and D obviously cannot be equal, right? N is also equal because they are reading on the same day, but N is the one we have to find. And also Tn is equal. They are reading the same number of pages. So Tn gives you the number of pages. So Tn is equal. So you are going to equalize both the equation using Tn. That's what we are going to do. Right? So for Amala, if you apply Tn is equal to, first term is 20. They are reading on the same day. Same number of pages, we are finding on which day, that is n here, n minus 1, common difference is equal to 3. I'll mark it equation number 1. Then for Sumana, we know it's 8, 12, 16 likewise. Again, we can apply Tn equation, 8 plus n minus 1. Here the common difference is 4. Now we know we are finding out the day where they are reading the same number of pages. Tn is the same number of pages. So Tn in both of them are equal. Now what can I do? I can equalize 1 and 2. So 1 is equal to 2. Now I can tell 20 plus n minus 1 into 3 is equal to 8 plus n minus 1 into 4. Did everyone understand this? Yes or no? Any
Yes,
doubt
sir.
here by derive this equation? Any doubt?
No, sir.
Yes, Ashiva? Any doubt?
No, sir.
No. Right. So now what we can do, simply solve this equation, find the value of n here. Multiply 3 and n here, 3 and minus 1. So 20 plus 3n, 3 into minus 1 minus 3. 8 plus, open the bracket, 4n minus 4. Right? So 20 minus 3, that is 17. 3n plus 17 is equal to 8 minus 4, that is 4. 4n minus 4. Right? Now what we can do, take all the n to one side, numbers to one side. Always keep the n positive. So I'll take the 3n to this side, minus 4 to this side. Okay? So I have 4n, 3n if I take here minus 3n, that is equal to 17. Minus 4 if I take here, it will become plus 4. I'll write it here. 4n minus n, that is n, that is the on which day n is the one we need. 17 plus 4 is 21. That means on the 21st day, both Amala and Sumana will read the same number of pages. Is that clear, everyone?
Yes, sir.
Right. Have any doubt? You can ask me now. Yes. Anyone?
Yeah, is this
No?
step similar to simultaneous equation?
Sorry, Aisha?
This step similar to simultaneous equation?
No, not this is not a simultaneous equation. Here, now let's say they tell you to find the number of pages, then it becomes a simultaneous equation. Then you have two unknown terms. But yes, it becomes a simultaneous equation. But here they are asking you the value of n only. So then these both are equal. So you can equalize both of them and find the value of n. Understood?
So,
Yes, Ibrahim.
so 8 minus 4 is plus 4, right?
8 minus 4. Yes. Thank you. 8 minus 4 is plus 4. Yes. Then, yeah, 13, right? Be 13. Okay now.
Yes, sir.
Right, good. Thank you. Any other? All right. So then can we stop here? Right. Then next class, I'll let you know. I'll let you know. It will be on Tuesday, right? Same day, Tuesday from 10 to 12, right? So I told you on the previous class why we changed, because Asim is informed that's already Wednesday. You guys have a lot of classes. So again, joining night class will be a bit difficult. So that's why I changed on Tuesday, right? So then on the coming Saturday, Vehivala will be starting trigonometry. Right? If you guys want, you can join, right? I think trigonometry, right? Wait. If you want to join the class, you can drop me a message. Yes, right. We'll be starting trigonometry. It will be going for 2 classes, right? So trigonometry is again one whole essay question, right? So it'll be going on for 2 classes. You can drop me a message for further details on how to join the class. And just for those 2, even if you want, just for those 2 classes, you can join, or you can join for the whole month as well. It's up to you, right? Just drop me a message. I'll give you further details. Right then. Good night, everyone. Thank you for joining. Take care. Assalamu alaikum.
Bye, sir. Good night.